Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face Trending List, published on December 19, 2025, about 3 days ago. This paper introduces Seed Prover 1.5, a formal theorem proving system for Lean that learns from experience with large-scale agentic reinforcement learning and an efficient test time scaling workflow, and it reaches about 88% on Putnam Bench, 80% on Fate H, and 33% on Fate X. The paper is titled Seed Prover 1.5, Mastering Undergraduate Level Theorem Proving via Learning from Experience. Okay, as we go on, the way it bridges natural language proofs into verifiable Lean steps is going to be the really interesting part. Also, the author shared a GitHub repo that acts as a hub for the Seed AI 4 math projects. You will find separate folders for Seed Prover 1.5, the earlier Seed Prover system, and Delta Prover, along with Lean formalizations and notes on their Putnam Bench and Putnam 2025 results, plus IMO 2025 proof details. Figure 1 makes the main claim concrete, because it shows Seed Prover 1.5 outperforming other provers across several benchmarks. The full bar chart summarizes solved percentages across Putnam Bench, Fate H, Fate X, Combi Bench, and Putnam 2025. The left cluster highlights Putnam Bench, where Seed Prover 1.5 reaches about 88%. The middle clusters show Fate H at about 80% and Fate X at about 33%, which signals the remaining gap at PhD level. Figure 2 explains why the system can be both strong and efficient, because it proves in small lemma-sized chunks instead of dumping one huge proof. The full diagram lays out a loop where the assistant writes a step, then Lean verifies it, and search tools help when the model gets stuck. The key idea is caching, which means reusing already verified lemmas, so the model does not have to regenerate them. The Lean context panel shows that verified lemmas get saved and added back into the working context. Table 1 makes the efficiency story feel real, because the agentic prover alone beats a heavier workflow on the same math benchmarks. The full table compares approaches across Putnam, Fate H, and Fate X. The Seed Prover 1.5 row shows higher solved counts than Seed Prover 1.0 medium, even though the budget is expressed as pass at 8 by 8, which means multiple parallel tries with a fixed attempt budget. Figure 6 shows that spending more test time compute steadily buys more solved theorems, but with diminishing returns. The full figure contains 2 panels that connect budget to outcomes on Putnam Bench, so it clarifies why search matters. The left panel plots total solves versus compute per problem, and the curve rises roughly log linearly. The right panel is a histogram of solve time, which spikes in hour 1 and then stretches into a long tail. Table 2 shows that the system delivers better proof solving per unit of compute than several well-known competitors. The full table compares compute budget on the left with solved rates across Putnam, Fate H, Fate X, and Combi Bench on the right. Seed Prover 1.5 uses 10H 20 days per problem, yet it reaches about 88% on Putnam Bench, which beats the higher budget Seed Prover 1.0 medium setting. The same row also reports about 80% on Fate H and about 33% on Fate X, so the hardest tier still remains challenging. Alright, 2 takeaways stand out. Seed Prover 1.5 shows that learning from experience with Lean verification can push formal theorem proving to strong undergraduate performance, while also cutting proof search waste through lemma-sized steps and caching. The broader implication is that hybrid natural language to formal workflows can make verified math far more scalable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.